the main theme, you guys, for this unit is composition of functions. We're going to learn about one-to-one functions and inverse functions. But before we start doing that, and maybe we will today, we need to review, for some of you it's review, for some of you this will be new, how to work with complex fractions. And all that means is that within, you see the large numerator here? And the large denominator. Within each of those, we have fractions potentially. Okay? Big packet right over there. And so we're going to talk about the easiest way to clean these up and make them look nice so that we can actually work with them in other contexts. Okay? So first, let me just review things that we've seen already. Okay? If I gave you the fraction 2/3, and I wanted to divide that by, let's say, 1/2. Do you guys remember how we did this a long time ago? Mm-hmm. What do I do instead of divide by a half? Multiply by the reciprocal. So instead of doing dividing, we multiply by the reciprocal, which is 2/1. And so our answer here would be 4/3. Look familiar? Okay. Well, this is one way to do these complex fractions. However, it's not the only way and it's not the easiest way. So I'm going to show you what the preferred method is for complex fractions just with this little problem here. Okay? So option 2 looks something like this. Now, if I look at both of these little denominators, the 3 and the 2. What is the least common denominator there? 6. That least common denominator, that least common multiple, we're going to multiply numerator and denominator by 6. And what that does for us is cancel out. That's what we like to do. We like to cancel out all the tiny little fractions. Cancel out the 3, because what's 6 divided by 3? So now it's really just 2 times 2, which is 4. And what's 6 divided by 2? Times 1, still 3. Okay?
Wait, how did you get 6 3 times 2?
How did I get?
6.
Because 3 and 2 is the least common multiple of 3 and 2.
Yeah, okay.
Couple of ways. 6 divided by 3 is 2, so 2 times 2 is 4. 6 divided by 2 is 2 times 1, or I'm sorry, by 2 is 3, times 1 is 3. Right. The other option is this. You can go straight across. 2 times 6 is 12. 12 divided by 3 is 4. 1 times 6 is 6, divided by 2 is 3. Okay? This option here, the least common denominator, when you multiply a fraction by the same thing in the numerator and the denominator, it doesn't change the value of the fraction. For example, imagine a pizza. If you eat half of it, there are many ways that you can eat half a pizza depending on how it's cut up, right? If there are 8 slices, how many slices would you have eaten? So imagine 1/2. If you multiply by 4 on top and bottom, that's where we get the 4/8 from. You see what I'm talking about? If the pizza's cut into 6 slices, we can multiply this by 3 to get 3/6. All of these fractions, even though they look different, are still essentially 1/2. Does that make sense? So what we're doing here, multiplying by the LCD, does not change the fraction at all. It just makes it look a little different. Okay? Now let's see if we can apply this with algebra. So let's look at the first example. What are the little denominators that we see?
X.
Just x. That's a great thing for us because we don't have to figure out what the least common multiple is. If we want to cancel x in the numerator and cancel x in the denominator, we can do that by multiplying by x. And the rest is just algebra. What is x times 1? X plus, and now the whole point of doing x times 1 over x was that when you divide x with x, these will cancel out what's left. 1. So there's my new numerator. Okay? And now I repeat and do the same in the denominator. X times 1 is x minus, and then what's going to happen with the second fraction? Cancel the x's, you get 1, there's your answer. Does that make sense?
Simplifying it, we're not solving it.
Yeah, there's no equation to solve. We're just trying to get it as nice and simple as possible. Yes?
Like now you have the 1, then you have the 1 over x. But then you put the x on the outside, so you have the x on the outside. What are you multiplying or dividing first? What is it?
So there's a couple of ways to do it. I'm going to show you this once. I'm going to show you this once so that it helps clear up the concept. Imagine 1 is 1 over 1, okay? And we're multiplying each of these fractions by x. So what we're really doing is multiplying by x over 1 and by x over 1. Does that make sense? When you multiply these, you get just x. Because x times 1 is x, 1 times 1 is 1, x divided by 1 is just x. Does that make sense? And now the second part, 1 and x give you x over x, but x divided by x is just 1. That overcomplicates it, though. I'd rather have you look at this and say, well, these x's are going to cancel out because we're dividing, and here we're multiplying by it.
What are we dividing first? Like the 1 over x?
You have to go both ways.
Oh, yeah, the arrow is top.
Yeah.
Okay.
Is that what the... Yes.
Yeah.
Okay. Let's try number 2. What little denominators do you guys see here? Just x minus 1. There's nothing else going on, right? So if we want to cancel out x minus 1, I got to multiply by x minus 1 in the denominator. But I can't just do the denominator. I have to do numerator as well. You can't do one thing and then not the other. So even though there's no fraction up here, I still got to do it. Okay? What's 1 times x minus 1? X minus 1. And now imagine this getting distributed to this fraction. If I distribute it to the numerator and then divide by it, what happens? It cancels out, and what's left? Just 4. Does that make sense? Plus, and now here, this 2, there's nothing canceling or dividing this out, so I'm going to have 2 multiplied with x minus 1. Does that make sense, you guys? Okay. Don't cancel anything out yet. Okay. If some of you are going, ooh, x minus 1s, they don't cancel because we have an addition sign. Yeah, and we're violating order of operations. So first, you'd actually have to combine your like terms. Distribute the 2. What do we get? 2x minus 2. And now we can combine. We get 2x plus 2. And now look, we would maybe try to factor and cancel, kind of like last unit with the fractions, right? What could I factor out here?
2.
If I make this 2 times x plus 1, does that help us? It doesn't cancel anything out, actually. So you could leave your answer like this, or if you wanted to rewrite the denominator like that, that's fine too. But you do want to see if you can factor and cancel, because sometimes that'll happen, and you want to know if that's the case. Okay? Are you okay skipping these 2 here? What do I multiply the number 3 by? What about here? Okay, so maybe we should do 4. Okay? We have an x that we want to cancel. And what else? A 2. So I need to multiply by 2x. 2x would be the least common multiple, or the least common denominator. Okay? So now again, try to visualize what's going on here. What's 2 times 2x? 4x. Plus, this x will cancel with the x there. So what's left to multiply? 3 and 2 is 6. Good. It's a little tricky at first, but once you do a couple of these, it's not too bad. Now down here, this 2, again, it needs to cancel. But what is it going to cancel with? The 2 out here. So what's left? X and 1, which makes x when you multiply. Minus, what cancels here? X's cancel, but I still got 1 and 2, which make 2. And now, I mean, you could try to factor. What's the GCF up in the numerator? So maybe this is 2 times 2x plus 3. Will that help me, though? No, not in this case, but we do want to check. Okay, so this answer is fine, or this one is okay, too. Either one of those is going to be perfectly acceptable as your final answer on an exam. Okay? Make sense? Okay, let's go to page 2. Let's just jump to the hard ones. You guys seem to be doing pretty well with these. Let's go to 7 and 8. Okay, let's see how we do with those. Okay. How many little denominators do you guys see?
2.
Plus 8. By the same thing, right? Okay. And so now very slowly, x's. Cancel any of this out. X. Are there any questions? Contributing? Okay.
Yeah.
Put parentheses down, getting smaller. The next step, as long as, so it's not 9, we do add it like this. If I had an 8 up here, right? Yes, factor it all out. Then let's go ahead and just stop there. We finished a few minutes early. You might be able to get your homework done now. There's only like 4 or 5 of these questions. You could probably at least get half of them done in R7, I believe.